All right, good morning, everybody. My name is Tony Andrews. We have a little 45-minute webinar today, Developer Best Practices for DB2 Performance. I'm a trainer with Themis. My email is right there on the screen, tandrews@themisinc.com. At Twitter, you can follow us at Themis Training. I do a lot of DB2 classes. I tend to stay a little bit more on the developer side. That's my background. I do a lot of SQL, advanced SQL, performance and tuning classes for developers, and kind of been on a roll for a number of years here to try to get developers a little bit more educated in some areas of DB2 performance. So that's what this webinar is going to be about. We're going to hit some of the main things that I think developers should pay attention to and get to know, be familiar with as they move forward in trying to get a query and/or program going better. And because oftentimes I find with developers, they may have a query or a program that they're working on that they think should run better, or somebody mentions to them maybe it should run better, and oftentimes they're not quite sure where to start. Where do I start? What do I do? What could cause some of this my program and/or query to run better? And that's what this webinar is all about right now. Right now, I kind of understand it. Okay. So, any questions that come up, I'll try my best to get to some questions towards the end of the webinar. You can submit questions by typing into the questions area of your webinar control panel. Any questions not answered due to time constraints can be answered afterwards via an email. So we're going to talk about a few things here. What are the key areas that cause performance issues with DB2 queries and applications? A little bit better understanding of DB2 optimization. DB2 database design, that has an effect on performance. There's a lot of different areas that have an effect on performance that we're going to talk about. Statistics. DB2 needs to know in the optimizer, some cardinalities, for example, and some kind of unique statistics that we're going to talk about to help it choose the best access path. So how does statistics affect performance? How does database design affect performance? How does our SQL coding affect performance? A lot of different areas here we're going to talk about. So let's get rolling. So DB2 optimization. So let's just talk about the optimizer in general. DBAs come along and they do the create tables through their SQL DDL statements. And when they run these create tables and these create indexes and all these other things that they create, the statements in a query tool will typically come back and say, hey, create successful. Well, what actually happens behind the scenes is those objects that they're creating, the names are put into the system catalog tables. DB2, like many relational database systems, has a whole set of relational catalog tables that come with the system. So in DB2, all the system catalog tables begin with SYSIBM as the owner, creator, schema, dot, systable, syscolumn, sysindexes, sysviews, sysforeign keys. And when they create these items, these names go into these associated tables. That way DB2 knows in each environment what's been created. Thus, if we go to type up some queries and mistype a table name, and you get a minus 204, you mistype a column name, you get a minus 206. It all has to do with those where DB2 does not know of the words that we typed in, the names of the columns and the names of the tables. They didn't come along and they run statistics after we get data loaded. The statistics actually updates these tables, these catalog tables, to give DB2 some cardinalities on how many rows are in the table and some of the cardinalities on the columns in the table of data. We'll talk about those a little bit more coming up here. So when you send a query to DB2, either in a dynamic mode or if you have a package and it goes through the bind, DB2 is coming up with the access path. So It looks at the object definitions. It'll look at the from statement. What are the tables involved? It'll go look up those object definitions and see some things that it knows about the table, the column names, the data types of the column names, the indexes, so on and so forth. It's going to look at any statistical information that's been updated in there. The tables involved. How many rows are in the table? Is it a partition table? What are the indexes on the table? How's the SQL coded? Is the SQL coded in such a way that I can take advantage of some of these indexes? And how's the SQL coded to give me an idea of how many rows are going to be coming back out of my result set? Part of one of the access paths, or a few of the access paths, goes into something called a list prefetch that we won't get into today. But there's a couple of different kind of sorts that go on in SQL processing. One is data sorts, where you have group bys and order bys and the distinct and the union versus a union all cause some data sorts. There's also these items, these RID addresses that sit up in these index files, that oftentimes we have a process called list prefetch that DB2 will take these RID addresses out of the indexes and sort them in what's called a RID pool. So RID pools are sized. Sometimes our sizes in tests could be a little bit smaller, not the same size as what we have in production. Okay, so it takes all of this stuff into account and comes up with what it thinks is the best access path. Okay, and maybe that access path is not running all that good. So we kind of get to, all right, what do we do? Where do I start? And that leads us to our next screen here. So as a developer, we have a number of things we can start looking into. Sometimes we need some help with a DBA. Sometimes we're kind of empowered to do a lot of things ourselves to get things to run better. Changing the physical design. Now, obviously, this we tend to have to get a DBA involved, but are there any indexes I can add or any indexes I can change? Or the clustering order of the data in the table we're going to spend a couple minutes talking about here, or the partitioning scheme. There are some physical things that we as developers need to pay attention to, and the queries that are going after that data, is it partitioned the right way? Is it clustered the right way? Do we have the right indexes on the tables? So this is something that we can dig into and we can figure out. We can query the catalog tables. If you have nice GUI tools to run your queries on, you can typically do drop downs and you can see all kinds of the indexes on a table and the columns and definitions and that kind of stuff. Statistics are quite a big part of the optimizer picking good access paths. What's the number of rows in a table? And for each column in a table, what's the cardinality for each column? And what do I mean by that? If you take an employee table that we have in our IBM sample tables, the employee table has a column called empno, and it has a column called last name, and a column called first name, middle initial, the department that person works in. So the column cardinalities are how many different employee numbers are there in the data in the table? How many different first names, last names? How many different department number values are there? Maybe we have 28 departments at a company, but maybe only 16 of those departments are actually assigned in our data. That's kind of a good thing to know for us to know as knowing your data. Also for the optimizer to know how many different values are there, because that comes into play in picking access paths and coming up with the number of rows that it thinks is going to meet our criteria for our result set. So we want to pay attention to that, and we're going to see it here in a few more slides. We're going to get a little bit deeper into statistics and talk about some frequency values, some more specific statistics that can help us at times. Changing the SQL. This is where we are really empowered. I have in red there, see a prior webinar, The Power of the SQL Rewrite. I did a webinar, I think it was earlier this year, and it's right along this line. Oftentimes there's 3, 4, 5, 6 different ways you can write an SQL statement to get the same results back. Like if you're looking to see if something exists in another table, I mean, there's easily 3 ways to do that. If you're looking to see if something doesn't exist in another table, there's easily 3 ways to do that. And I know in a lot of our advanced SQL classes, we go over a lot of this, all these different ways that we can generate the same result sets. Now, why is that important? Because as you write queries different ways, okay, that gets the same result set, oftentimes physical things happen differently behind the scenes. that DB2 will actually do things physically different in gathering up our result set than it did a different way that I coded the SQL. So if I have a query that's not running very well, one of the first things I always tell developers, hey, without ever really even knowing what's going on behind the scenes, can you think of another way to write the query? And when it comes to predicates, which is each of the statements in your where clause, you know, where last name equals Andrews and first name equals Tony and so on, each of those is called a predicate. Oftentimes we can write predicates a different way that will still maintain our logic and get the same results. So oftentimes even changing one predicate and rewriting it a different way can cause the optimizer to possibly choose a different access path. Now, remember, I'm saying it might do it. You might get in and change something, change a predicate rewrite or change a query rewrite, and nothing changes in the optimization path. How do I know if something changes in the optimization path? Well, you're not going to know unless you go and do a DB2 explain and see if there was actually a different path, different index, different order of the tables, different join method, maybe some sorts went away, that something changed in the rewriting of the query. So anytime you can think of a different way to rewrite a predicate, or anytime you can think of a different way to rewrite a query in general, try that in your testing. And I can tell you, I've been doing performance and tuning consulting for a lot of years, and I still do it today. I swear probably 85% of the time when I go in to get things to run faster, all I do is change people's code. I change the queries. A lot of times I change the design of the programs. The other 15% of the time we change physical design and we alter and gather more statistics. Okay, so that means if I see from my end, most all the time I can get things to run faster by just changing code. That really empowers us developers that we can do these things without having to go to a DBA or go to some team, you know, to help me out. Okay. So that's a few areas right there that have huge effects, probably the biggest effects on what makes queries run good or they're not run good. As far as the statistics are involved, most of the time in production statistics are pretty current. You know, from DBAs running statistic jobs weekly, monthly, quarterly. In our test environments, we tend to be out of sync a lot. And this is where you have to kind of pay attention. Statistics might have been run in a test environment 4 or 5 months ago, and at that time, maybe the table that's in one of my queries had 18 million rows in it. But right now, it may only have 2 million rows in it, or maybe it now has 110 million rows in it. But as far as DB2 knows, the last time anybody ran run stats in that test environment was when 3 or 4 months ago, and there was 18 million rows in it. That's all DB2 thinks is in it. So we need to pay attention to this in our test environments. You know, we need to make sure that the statistics are pretty close to reality in our test environments. In production, they're pretty close to reality on a pretty consistent basis. All right, let's go to database. Let's go to the next page here. Database design. Okay, and let's talk about a couple things here. Indexes. Okay, what are they good for? Well, they're good for a lot of reasons. They enforce primary key unique constraints. They support foreign keys. When you join tables between a couple tables in a join query, we join by primary key to primary key or foreign key to primary key. We need to make sure that all those primary and foreign keys have indexes on them. Primary keys are going to be there because they specify a primary key. They're forced to put an index on it. Sometimes foreign key column indexes are missing. So they're pretty good at keeping up on this, but they're not forced to as they design these tables. So we need to make sure in support of the foreign keys that we have indexes created on those. So the indexes, just like number 3, supports the SQL join processing. Indexes used to be used and can still be used to define table partitioning. It's an old requirement. Currently, it's an option. There's better ways to define your table partitioning at the table definition level. Obviously, number 5 is where it really hits for us. They improve performance in queries. Okay, without indexes, DB2 would choose to do table table scans, a full file scan. That's typically not good. So one of the things I tell developers is if you ever see a table scan, if you do explains, you see a table scan, that should be an automatic flag. I mean, out of all my years of coding, very, very seldom, probably 1% of my queries did I really want it to do a table scan. All the other times, I just want a portion of the data back, and an index was always what was best to get my best response time. So I tell developers, look, if you're getting a table scan, that should be an automatic flag. Let's look in to see why the table scan is occurring. Number 6 is one I want to talk a couple minutes about here, and that has to do with one of the indexes will specify the clustering order of data in the table space file. So when they create a table, they also create a file for the data for that table to go into, and DB2 is called a table space. Okay. One of the indexes will define how the data should be ordered in the table. So take our employee table here, one of the DB2 sample tables. Again, you have employee number and the first name, middle name, last name, the department they work in, the salary they make, some other columns. How should that data physically be clustered in the file? Should it be in employee number primary key order? Should it be in last name order? Should it be in hire date order? Should it be in department number order? I mean, how should the data be ordered? And this is what we're going to spend a couple minutes talking about here. Okay. So one more screen here on indexes, and then we're going to talk about the clustering. This is kind of the few little bullets on index design. Design indexes that match predicates in your queries. One of the things that may have DB2 not choose to use an index and do a table scan is maybe I have where salary is greater than 50,000 and bonus is greater than 20,000. And when I look, I don't have an index on salary. I don't have a bonus. I don't have an index on bonus. So DB2 by default saying I don't have an index I can use. I have to do a table scan. So we want to take our more common queries and the more common columns that we see queries come in for and design indexes that match those columns. Read-only tables typically have more indexes, like data warehouse designs. Okay. The more indexes on a table, the more I/O takes place on inserts, updates, and deletes, because these actions also manage index values in those index space files. Reorgs will also run longer. So this comes up like often from developers. I go, why don't we have 8 or 9 or 10? Why don't we index a whole lot of columns? And you can index a whole lot of columns, but you kind of have to weigh out and know your application. Do we have a lot of inserts, updates, and deletes that go on a day-to-day basis? Because if I have a table that has 5 indexes and I do an insert of a new row, there's actually 6 IOs that are taking place behind the scenes, 1 to the base table and 5 more to each of the indexes, because that new row has to be known in the index files. The indexes are separate files. So we kind of have to watch out for that. And if you ever update columns that are part of an index, there's even more overhead involved in that. So you go to number 4. You have to know your application. What are the most frequently executed queries? How often these inserts, updates, and deletes executed? And that kind of helps us drive, with the DBA's help, typically, the indexes that go on a table. Queries with table space scans. If you see one with a table space scan, we need to look and figure out why it's doing a scan. How often are they run? If it's run once a week and the scan runs in a couple of minutes, maybe we don't worry about that one so much. If I have a table scan that runs in 5 or 10 or 15 minutes because it's a really large table and it's run 25, 30, 50 times a day, then we probably need to do something about that one. All right, let's talk about indexes for clustering. One of the indexes is going to define the clustering order of the data in the table. So how the data is physically ordered in the table space file has a huge, to me, a ginormous effect on performance. Okay. This is an area that I see gets ignored often in applications. Okay, so operations that benefit from good clustering design are queries that return a high number of rows. Our online transaction processing, online screens that bring back 1 row, 2 rows, 5 rows, hardly any rows except for maybe our search screens. The way we physically order the data in the table really has no effect because it's hardly bringing back any data. So we want to look at our queries, either on the online side or queries in our batch cycles that return the high number of rows. a lot of the queries that have groupings involved, you know, where they're going to gather up a lot of rows to group. A lot of it has some ordering, a lot of the join operations, a lot of the queries that have range type predicates. And what do I mean by range type predicates? Those are the ones that have greater than or equal to, less than or equal to, a between, a like is a range type predicate. Okay. Those are the ones that we want to pay attention to, and those are the ones we pay attention to because that's going to define to us how we're going to physically order the data in the table. So let's go to this next screen here, and let's take a look at our employee table. So as many of you probably already know, these physical files that house our DB2 data are these linear data set files behind the scenes, and they're broke up with what they call pages of data. Most of the DB2 tables out there have pages that are 4K, 4,000 bytes in size. There are table designs that you can make larger page sizes. Most of them are 4K. So on a 4,000 byte page or chunk of that physical file, we have so many rows of data. So this is an example of the employee table. It happens to be an employee number order. Employee number is the primary key of this table. What I find in applications out there over the years is I find that most tables, except the partitioning tables, most tables end up being clustered by the primary key. Okay, why is that? Because the way the DBAs go about creating the tables early on in the process, creating the indexes, the primary key is usually the first index that's created, and that becomes the default clustering index. One of the indexes is what defines the clustering order. So when they run reorgs and loads and all that kind of stuff, DB2 knows what the order of the table should be. So the question comes up here on the screen, should this table be an employee primary key order? The answer is it depends. I find in my personal experience, having tables in primary key order is typically not the way they should be. Because when you look at our batch cycles, you look at these queries that gather up a lot of rows of data, they're not going in by big ranges of primary key values. They're usually coming in by looking at some kind of like policy types or some kind of dates, you know, to gather up data. You know, what are all this stuff that happened today? What are new policies today? You know, or some other field other than a range of primary key values. So if I look at an application that takes this employee table into account, and I look at the way the queries go after this table, and I see a lot of queries that are grouping by department number. I see a lot of queries that you put a department number in, it gets all the detailed data, all the employees for a particular department number. And I see most of the joins to this table is by department number. And I see averages and mins and maxes by department number. Well, that kind of leads me to believe when I look at these queries that are doing a lot of these groupings and range predicates and joins by department, this table should be in department number order. Because if you look at a portion of this data here on the screen and you come in with a query that says, select from the employee table where department equals A00. Okay, let's go to this next page here on that one. So we come in with a query that says where department equals A00. So if the data is clustered in employee number order, where are all the A00 rows in the table? They're scattered. They're not clustered together. The data is clustered by employee number. So maybe there's 100 people that were part of department A00. They could be on 100 different pages. As DB2 builds our results set and retrieves our data, it gets a whole page of data. It's called a get page in DB2. It could possibly do 100 get pages to bring back my 100 rows. That's not real efficient. Okay. If it was clustered together by department number, I could probably have all 100 on one page, maybe two. Okay. So our get page counts in the retrieval process, the I/O, becomes much less. So it's something we as developers really need to stay on top of. We can't rely on a DBA to get it straight, because when applications and new tables are being built, they don't know everything that's going to drive the application query-wise like we do as developers. So we have a big impact on this. we need to pay attention to this as we're going through development. We need to put on our calendar sometime in a development process, let's go back and look at the clustering order in some of these tables that get queried thousands of times a day and have big batch jobs at night. Because once a table gets put into production, and it's in production for a while, it is not an easy process to try to get a company to recluster the data. Because reclustering just takes on a whole new and big project. We have to retest everything, every query, every program that touches that table, to make sure that some of them that we know is going to help, that it doesn't hurt others. We can't just automatically change them in production. A lot of companies say, well, we don't have time for projects like that. We have other stuff going on. So just keep that in mind. New tables, new applications, pay attention to this, because most of the tables that go into production, they go in primary key order, and that is not always the right order, and it just really hurts performance. Okay, let's talk about statistics here a little bit. So this next page here. So Runstats. Runstats is a utility. It puts data distribution statistics in the catalog tables. It updates the catalog table. So if I run a Runstats utility on our employee table, it's going to go to the SYSIBM.sys tables, and it's going to update in there a cardinality field that says how many rows are in that table. It's going to go to the SYSIBM.sys columns table, and it's going to update for every column how many values are in that table at this particular time on this day. Okay? As data changes, and this often happens in new applications, is we may go live with a new table or new application, and maybe today when we first load it, it has 1 million rows in the table. Well, 6 months from now, it's got like 12 million rows in the table. Well, that's where statistics come into play. Statistics, if they run those statistics regularly, they're going to update these statistics in the table. So now 6 months later, DB2 knows there's 12 million rows in the table. Okay? This is really important. As we pull programs out of production and we move them back into production and we rebind the programs that we're working on, DB2 is now going to take another look and go, oh, wow, there's 12 million rows in the table. Well, let me figure out what I think is the best access path based on 12 million rows. Okay? These are called cardinality statistics. There's some other kind of special statistics that we can do with a DBA called frequency value and histogram statistics. And I want to talk about those a minute, because oftentimes DBAs don't know these particular columns that maybe they should run frequency value or histogram statistics on. So it really relies on us developers to catch these columns with certain distribution of values and talk with the DBA about getting some special statistics out there for them. So let's go to the next page here and let's take a look. Let's say in our employee table, besides the first name, middle initial, last name, department, there's a salary, what salary they make, what they have a bonus, what's a commission? They have a commission amount. So let's say in our table of data, our commission has 31 different values across all the data. But when we get to analyzing the data, we get to writing queries against the data, we realize that the value 0, which is one of the 31 values, is 99% of the data. Wow, that's a very uneven distribution of those 31 values. That's an outlier. That's something we need to talk to a DBA about. Like, look, we have this column that we query against often, where that column commission is in our where clause fairly often in a lot of our queries. And we're putting specific values in there. And sometimes we're looking for the ones that don't have a commission. So we're looking for commission equals 0. Well, if DB2 does not know anything specific to that value 0 versus other values, then it's going to assume a certain amount of rows that's not real. Okay, it's not going to match reality on what we code. So we get with a DBA and we have them run a special statistics called frequency value. Frequency value puts in the sys column distribution table that says this column commission for this table employee for the value 0 is 99% of the data. Okay, So now DB2 knows that that value is one of these outliers. That means any other value, the other 30 values or any other values that come along and get added or updated, they're all going to be less than 1% of the data. That's step one. Step two is us as developers, we need to let DB2 know in our queries that we're going against the column, the commission column that's equal to 0, or we're going against a commission of a different value and it's not 0. And I have a couple of examples, right here, where I say, and commission equals 0. So if that hard-coded 0, hard-coded value goes to DB2, DB2 can look that up. It's going to look at any hard-coded values. It's going to go into the catalog tables and try to figure out if it knows anything about that value or anything about any other hard-coded values. So if it sees 0 in there, it says, oh, 99%, well, that predicate is hardly filtering any data. If I come along with what the second box there at the top, it says, and commission equals question mark as a parameter marker, DB2 is going to go, I don't know. I have no idea what value you're going after as I'm binding this program, but I know you're only going after one value, and I know there's 31 values in the table. So I'm going to automatically assume some even distribution. Now, and that predicate there, I think you're going to get 1 divided by 31% of the data based on that particular predicate. Well, 1 divided by 31 doesn't really meet any value I put in there. So when we put some hard-coded values, when we see some of these columns, and we see them as developers, DBAs typically don't know these. We see them because we're in the data, we're in the code on a day-to-day basis. If I go for any other commission value in my query that's not 0, then I code what I show in the bottom box. I put my commission equal to, and I can reference a, I could have a host variable there as a parameter marker, which could be any value coming in, but I also need to let DB2 know that, hey, what's sitting in that host variable is not going to be equal to 0. So DB2 is going to go, well, what do I know something about 0? Oh, that's 99% of the data. That means the value that you're looking for in the host variable, no matter what the value, is going to be like less than 1% of the data. Okay. All right. So there's some other special statistics too, like histograms. We don't get it. I don't cover that in this particular webinar. But I'll tell you a little bit about them. And it takes a special run stat, from the DBA. You need to work with the DBA on this. So this is when you have maybe thousands of values across a column, and there's no 1 or 2 or 3 values that really stand out with a high percentage of data. But there's groups of them, what we kind of call hotspots at times in the values, like maybe maybe department values from P00 to P50. Those departments end up eating up 70% of the data in the table, and all the other departments make up the other 30%. Well, instead of running some frequency values on hundreds of values, but none of the values really stand out, we can run what's called histogram statistics, which will take those groups and put in the tables. It says from this value to this value is this percentage of data, and from this value to this value is this percentage of data. That really comes in handy for these range type predicates when you have greater thans and less thans and betweens and likes. Okay. So that's a little bit about statistics, a little bit of what we as developers need to pay attention to, and what we as developers can talk to our DBAs about. If I have a query that has 5 or 6 or 7 predicates in it, it could be this one predicate on commission that DB2 is thinking is getting more or less rows than it's actually going to get, could throw off the optimization. So any column that you come across that has some outliers or some really uneven distribution of data, and we use it in our where logic often, then we need to talk to a DBA about that. Okay. Talk about coding efficient SQL. This is where we are really empowered to get our queries good, clean, efficient, and give DB2 the best code that we can to pick the best access path. So we got a few slides on this. Writing efficient SQL queries. Okay, this is huge, you know, and you know, there's a lot of ways we can write predicates in the SQL language. A lot of the predicates are not very efficient, even though logically they work. Okay, so we need to kind of recognize which ones are efficient, which ones are not efficient, and are there any other ways we can rewrite these? So let's just kind of look at this list here. Are the SQL statements coded as simply as possible? Do I have a bunch of parentheses and ors and all kinds of crazy stuff in there? That makes it a little bit more difficult for the optimizer to try to figure out, wow, what is going to be my final result set? And wow, what path should I take? And which index should I choose? Are the filtering predicates coded efficiently? Okay, filtering predicates are these, not as opposed to a join predicate. Filtering predicate would be where last name equals Andrews. That's a filtering predicate. I only want the Andrews. Okay. Well, the way we code those predicates has a huge impact on performance. You know, as of version 10 still, if you put a function on a column in your where clause, then that predicate becomes what's called a non-indexable predicate. For example, if you say select the year of hire date equal 2009, DB2 may go look and say, hey, I got an index on hire date. Oh, but you got a year function on that hire date column in your where logic. I'm not going to use the index. One of the reasons for a non-indexable predicate. Non-indexable means even if there is an index on that column, DB2 is not going to choose that index or take into its costing that index. Okay? If you do mathematics on a column, you know, salary times 1.1 is greater than 50,000. You know, you do date mathematics, you know, hire date minus 7 days greater than something. Select the R trim of last name, select, you know, any kind of functions, any kind of mathematics on your columns and your predicates, the predicates become non-indexable and they get knocked down to what's called a stage 2. Okay, we don't have a whole lot of time to talk in detail about stage 1 and stage 2s, but predicates get put into these categories. We want everything at a stage 1 level. Stage 2s are more expensive. They tend to cause more CPU and more I/O in the running of a query. So how do I know if I have a stage 1 or stage 2 predicate? And the answer is you don't really know unless you do DB2 explains, and they'll lay that out for you. Or you have a listing of what is a stage 1 or stage 2 predicate. And you can get those out of the manuals. You know, you can paste them on the wall of your office if you wanted to. So we need to make sure our predicates are coded efficiently. Are there any stage 2 predicates? There's a lot of stage 2 predicates that can be recoded as a stage 1 predicate. Okay? Non-indexable predicates, oftentimes they can be recoded a different way. Are the codes coded efficiently? Are subqueries coded appropriately? You know, when it comes to subqueries, we have what's called correlated and non-correlated. You can take any correlated subquery and write it as a non-correlated. You can take any non-correlated and write it as a correlated. You can go back and forth. And developers should try both of those ways. Okay? And are there any aggregate functions? Okay? Do we need the aggregate function? Do I need any of the min-maxes and that? Do I need a group by in my query? Do I need an order by in my query? Do I need distinct in my query? Okay? Let's make sure we need those before we have them coded. Okay? SQL performance, know your data. Know your data. What are these columns that have the outliers? How many rows are in the table? If you're writing queries in your programs, what's the typical result set of a query coming out? If you're writing any batch jobs that go into production, you should have some audit trail in your output of your job that says how many selects, inserts, updates, deletes, open cursors, close cursors, everything you did on the DB2 side. You should have some audit trail that gets spit out so I could go look at any job and I could see what went on DB2-wise within that code. Whether it's Java batch or whether it's COBOL batch or whatever the programming language is. This, I find, is lacking tremendously in production code out there in the industry. When I get in to look at applications, you know, and somebody sometimes comes up and then we get to look at programs, there's no output that tells me what went on inside. That's knowing your data. The more programs get in the habit of doing that, the more they know their data. The more they know the typical result sets that come out. That can help us. That can help us when it comes to the problem resolution and incident reporting. Understand how the data is used. I mean, if I have data, do I have any batch processes, or is it all online transaction kind of processes? Do I have a lot of range predicates in my application? Write your queries efficient. We were talking about run stats is big. Get your run stats out there to gather the statistics. Validate through explain. I still find it amazing how many shops that the developers are not doing explains. Oftentimes management says they don't have time for explains. I tend to tell management, well, we always had time for explains, and all of our stuff had to be done last Tuesday also. It's not that hard to educate them. It's not that hard for them to do a quick explain, to at least look for some of the basics. So if you don't have explains going on, if you've never done explains, I would highly push that you get educated in that and you start doing that so you can get a little bit more involved, a little more intimate with what's going on in the running of the queries that you're coding. IBM has a tool called Data Studio that kicks out visual explains. This is a free tool. Maybe you have it at your shop. Outstanding, outstanding explain tool on the marketplace out there. And there's monitors and performance trace tools that shops have. OmegaMon and TMon and MainView and Performance Monitor and Strobe and on and on and on. Every shop has some of those. Get to know them. Have somebody show you the output of them. It can help you figure out some problems like pretty easily. Okay. So I know there was a question that came in. I'm gonna look that up here in a second. We got just a couple minutes here. Thanks for the 45 minutes here. Talk a little bit about performance tuning, what to look for, where to start, what you can do. Some of it takes a little bit more knowledge. Sometimes people cannot. They go, well, I'm not sure how to rewrite this predicate. I don't know what else I can do with this query. And this is where I think shops should have things, and I've always had them on every application I've been involved in, where we have these documents that say, hey, if you see something written this way, you write it this way. If you see it this way, you write it this way. If you're looking for existence, we got 3 or 4 ways to look for that. If you're looking for this, you got 3 or 4 ways to code this. And we put these documents out there, and we keep adding it, so all the developers can look at it. We have meetings on it. We review it. Good stuff. So if you don't have one of those, maybe get one going. So obviously, Themis, we're a training company. That's where most of our business is. We also do some consulting. There's some great classes. A few of them I listed here for us developers. DB1032 is a performance and tuning class. How do you read the explain? What do you look for in there? A lot of query writing, a lot of explaining in that class. DB1041, 3-day advanced SQL class. Outstanding. You want to get stronger in SQL? That's the class. You will get kicked up a couple of levels in your SQL knowledge in 3 days for sure. DB1037, another performance and tuning class. That's using the IBM Data Studio tool. Visual explains. DB1051 is a high performance application design. You have some batch jobs that are doing massive inserts, massive updates, massive deletes. What should I do? How should I code that? Well, there's a lot of options and a lot of ways you can code that kind of stuff. And there's a lot of it depends. And that's kind of some of the things that we go over in that class. DB1006 is a query tuning on the DB2 Linux Unix Windows platform. Okay. ThemisInc.com, you can find those courses. A little bit more information on them. I have a book picked up a couple years ago from IBM Press, Pearson Publishing, DB2 SQL Tuning Tips for ZOS Developers. I'm going to show that off here for a minute. Great stuff. Over 100 tips in there, page or 2 per tip. I can tell you I didn't put the book together to make money. You don't make a whole lot of money off these books. I put it together there because I find a real lack of education in developers in the marketplace, and there seems to be hundreds of thousands or millions of developers out there. And we all need to get a little bit stronger to get better performance, to save for IT cost and all that. So that's a great book there. And here we are, Themis Education. Got a lot of DB2 courses, a lot of IT courses. Okay. We also have a lot of DB2 version 11 courses too. I don't have that as a bullet on here, but we do have a lot of DB2 version 11 courses, transition courses for DBAs, and developer kind of topics that came up in version 11. Every time a new version comes out, we put some classes together for the DBA side, some classes together for the developer side. I tend to be on the developer side. That's kind of where I grew up and what I still do today. Okay. If I did not, which I did not, kind of ran out of time here, get to any of the questions that came in, I'm going to take a look at those, and I can get back with you via an email. Let's see if I can, well, we got about 12:20 here right now. Okay, so that kind of winds down our webinar for this morning. I'll look and see what questions came up, and I'll try to get back with you on those via email. Everybody have a great day. Happy holidays to everybody, and I'll see you down the road.